Alright, they want us to write the formula for determining the number of distinct proper subsets for a set with n distinct elements. So, formula is 2 to the n minus 1. And so we can test this out just to see what they mean. So 2 to the n minus 1 is your formula. So if I had a set with 3 elements, I would be expecting 2 to the 3 minus 1. So 8 minus 1 is 7 distinct proper subsets. So here I created an example. What if I had the set 1, 2, 3, right, with 3 elements, and I tried to list all the proper subsets. So I could have subsets with 0 elements, and that would just be the empty set. I could have sets with 1 element, so 1, 2, or 3. I could have sets with 2 elements, 1, 2, 1, 3, 2, 3. And note, I don't bother listing stuff like 3, 2, because that's not a distinct proper element, proper subset. 3, 2 would be the same as 2, 3. So that's what they mean when they throw in those distinct. The order doesn't matter. I went here and listed a set with 3 elements, 1, 2, and 3, but this isn't a proper subset because it's exactly equal to the original. So this is not a proper subset because it's the same as the original. So our proper subsets are we have 1, 2, 3, 4, 5, 6, 7 of them, and that matches what our formula told us. So if we have n distinct elements, we'll have 2 to the n minus 1 proper subsets. Alright, so going on to the rest of these, can any set be a proper subset of itself? No, because of what we were talking about before. If 2 sets are equal, one cannot be a proper subset of the other. So you can't, we didn't say that 1, 2, 3 isn't a proper subset of 1, 2, 3 because they're the same. We want sets that are smaller, totally contained within that set. Kind of wordy, but hopefully that makes sense. If it, let's see, skipping down to here, 3, 8, 11 is a subset of 3, 8, 11. True. Order doesn't matter. It's got the equal sign under it, which means it's strictly a subset, not necessarily a proper subset. So with the equal sign, it's okay for them to be exactly the same. So this is fine. Order doesn't matter. Skipping to 21. The empty set is a subset of the empty set. Sure, that's fine. All the elements in the empty set, which are none, are contained in there. That's fine. 26. Determine whether A equals B, A is a subset of B, B is a subset of A is a proper subset of B, or B is a proper subset of A, or if none of those apply. So for 26, X is a set of all natural numbers, and X is less than 6. And here we have X is a set of all natural numbers. X is an element, X is an element of the natural numbers, and 1 is less than or equal to X is less than or equal to 5. So if we were to write out A and B, this is a natural number less than 6. So the natural numbers less than 6, if I wrote them in roster form, would be 1, 2, 3, 4, and 5. And then for B, the natural numbers between 1 and 5 inclusive would be the same, 1, 2, 3, 4, and 5. So A and B are in fact equal. So A is a A is a subset of B, and B is a subset of A. But we can't say that they're proper subsets because they equal each other. Okie dokie. Oh, and by the subset of, like, all the elements of A are contained in B, and all the elements of B are contained in A. Okay. And 30, sports. X is the set of all X such that X is a sport that uses a ball. And we have basketball, soccer, and tennis, all which use balls. So all of B is a subset of A because all of B is contained in A. And B is a proper subset of A because all of B is contained in A, and it's not equal to that set because there are more sports that use a ball than just these three, so those two sets aren't equal. So all the elements of B are contained in A, but not equal to each other, so a proper subset. We're not allowed to say the reverse, that B is a subset of A. That A is a subset of B, because all of these sports are not contained in B. So all sports that use a ball are not in basketball, soccer, and tennis, because I could do like bowling or something. So A would not be a subset of B, because all of the elements in A are not in B. So I can't do this in reverse, is what I'm trying to say. Okay. Any more? 38. A set contains 9 elements. Actually, I'm going to pause it here.